Hi everyone, this is a short video on introduction to the online design marathon Vyom. Vyom or Vyoma meaning sky or heaven in Sanskrit. This competition is open to all engineering students and is organized by Beyond Apogee Private Limited. About us, we are a private company based out of Kathmandu, Nepal, and we are trying to work on research, promotion, and education of rockets, satellites, among other things. Currently, we are also conducting STEM-based robotics classes for school-level students. This competition is actually our attempt to get into the aerospace ecosystem in Nepal, be a part of the community, and get started with small things along with students. And I am Pravin Timilsina, and I'm working as a mechanical design engineer in Beyond Apogee. So the theme of the competition is thrust vector control. It means controlling the thrust vector, controlling the direction of the thrust. Through thrust vector control, which is abbreviated as TVC, we manipulate the direction of thrust to control attitude or angular velocity of rocket or other flying bodies. For the competition, you are supposed to design the thrust vector control mechanism. The requirements of the competition are CAD design, mathematical model, and a report and presentation. The report doesn't need to be very formal and there are no requirements for length but should be self-explanatory. And there will be a short 5 minutes presentation of the participants at the end of the competition. The CAD requirements are similar to every other engineering project CAD requirements. The design should be feasible, it should be detailed, you have to consider the positioning of the actuators, should consider manufacturing, and it would be great if you can make it 3D printable because we will make and run this mechanism after the competition. However, 3D printability it is not a requirement, it is an edit point. To the right, you can see an example of TVC mechanism. You can find this in the internet. There are two gimbals controlled by two actuators. There are only space for the actuators. This competition is a very open-ended competition and you can include any mechanism for TVC. Can even use something just like this as your submission, but try to include as much of these points as possible. Now for mathematical model, which is the control model, you need to prepare a closed loop control system which can change the angle of thrust based on the position and velocity data of the body. As said earlier, this is an open-ended theme and you can define your own mission. I'll give an example of a mission. For example, um, your rocket takes up from 0,0,0 origin and goes up, but there is certain disturbing force towards y direction. Then it travels to this side. A simplest mission would be that you would just change the direction. When the rocket goes up and its direction it changes to this side, then you can using TVC you can change the direction so that it goes towards positive z-axis again. So if you want to make it more challenging, you can define your mission as traveling along the z-axis such that when the rocket goes away, using TVC, the control will take it back to the original traveling line, which is z-axis. So this is up to you. More you challenge yourself, the better the results. For the first attempt, you can just try this simple mission. The checking criteria would be that your model would be tested for certain values of disturbing force in maybe x or y direction, and your model should complete your mission despite the disturbance. This is an example of a 3DOF mathematical model of the rocket, 3 degree of freedom. However, this is just an open loop system based on gimbal angle, defined gimbal angle. Um, Based on this defined gimbal angle, the rectangular components of the force will be applied to the rocket and its position will be given. But your task is to take this position, these positions that will come from this model as a feedback and change the angle so that you can complete your mission. For example, maybe go towards the z-axis. Similarly, this is the model of 6 DOF motion, 6 degree of freedom, where alpha and beta angle are changed. And I have applied a portion of 3D rotation matrix um, to resolve the forces like earlier. But you don't have to do exactly like this. There can be simpler and more straightforward methods. This is just a demo. In this case, you are supposed to take the values of angles, position, and velocity and use it to change these two angles such that the defined mission can be completed. Also, here you can see that I have applied a constant force as thrust. Later in your model, we will check with disturbance forces in different directions and see the results. We'll just add some forces to the forces that you have applied and check if the model is still able to take the rocket through the defined mission. So the data that are provided are rocket mass is 9.82 kgs, distance of CG from force application point is zero point 0.6 meters, longitudinal moment of inertia is 8.998 kg meter square, and rotational moment of inertia is 0.091 kg meter square. And for the thrust, while preparing a rocket sample, while calculating these data, we have considered this motor with this thrust graph, AL motor. It's a solid rocket motor, but you can consider any thrust graph you want, even a constant thrust with time, because it will be simpler and easier to implement. So, if it is easier for you, you can just assume a constant thrust, which is a reasonable assumption. You should take a reasonable assumption, and it will remain constant for whole time, because these uh, actual thrust curves only provide thrust for a certain period of time. Here the bond time is only about 3 seconds. Then the TVC can be implemented only for 3 seconds. So if you want to change the thrust curve, you can assume a reasonable value of thrust and even constant value if you require. So for participation, current engineering students can team up to a max of 3 students and register by paying rupees 500 uh, before Monks 12. The submission of the CAD files, numerical model files, and report must be before Monks 19, and there will be a short presentation after a couple of days after the submission. The first prize winner will be announced through Beyond Apogee social media page, and they will be awarded rupees 10,000. Although these four are the steps for the competition, it is not going to end there. After that, we will refine the design, work with the students, and develop and test the mechanism. And you can be involved in that if you want. So I hope you are interested in participating in this competition and you will learn a lot during the process. If you have any questions, any confusion, even about technical things or non-technical matter, you can find us at these contact places. And hope to see you. Thank you. All the best.